Healthy plants need healthy soil for healthy growth. To be able to precisely absorb what plants need, the soil needs to contain minerals and the necessary soil life. Research shows that the widespread use of synthetic fertilizer leads to soils that no longer have the required biology for healthy plant growth. Fertilizer comes from a time in which there was no understanding of the long-term effects on the soil. For farmers, fertilizer was a miracle. The harvests doubled, and growers were able to provide the required food for a growing population. But now, after years of using synthetic fertilizers, the effects on soil quality are apparent. Increasingly, it is seen that fewer nutritional minerals remain in the soil, resulting in plants that quickly become weak and diseased. They are no longer protected by bacteria and fungi, but instead are attacked by them. As well as this, using fertilizer means that these days, farmers need to plow deeper as the ground becomes quickly compacted. This is a costly business for farmers and is disastrous for the soil. There is a better way. It is not widely known, but the roots of plants are able to develop more easily in an environment rich in old roots. Here you can see the current plowing method, in which the soil is turned to 25 centimeters. This means that the plant really struggles to reach the thousands of passageways that other plants have created with their roots. They often don't even reach through the plow pan, which is caused by plowing the land with heavy machinery. A surface cultivation method can offer a solution to this. This shallow soil processing means that the roots are quickly able to access the passageways left by decomposing roots. In this situation, they only have to work really hard once they reach the extremities of the passageways. This means that they can root deeper year after year and ensures that there is even more soil and water available for growth. Dealing with diseases by spraying does little more than suppress symptoms. A healthy plant is able to keep most plant diseases out. In response to the negative effects of using fertilizers, pesticides are used to save the harvest. The conclusion we can draw is that plants that are only given fertilizer will ultimately always become diseased. Fertilizer is the direct cause of the use of most pesticides. In order to resolve the worldwide problem of over-fertilization, the vicious circle must be broken. The question that we must ask ourselves is, how can we improve the soil? The answer is surprisingly simple, but requires some explanation. Just like every other organism on the planet, a plant does not function independently. Health and growth depends on a partnership between specialist bacteria and fungi. Plants, fungi, and bacteria form a wonderful system based on trading products. How does it work? Fungi and bacteria supply nutrients from the soil that would otherwise be hard to reach. In exchange for this, plants supply sugars in the form of glucose. To explain this system, we will explain bacteria and fungi separately. Plants have a problem. Their fine absorption roots have a limited capacity. They only use 4 to 7% of the soil volume and are, on average, not thicker than a hair. They don't live long, only 1 to 3 weeks. As you can see, plants need external help. Plants use their absorption roots to forge a partnership. If they can't find partners, they'll die. If they succeed, it's the start of a beautiful relationship. From now on, a symbiosis can be created. Minerals are hard to mine from the soil, but rhizobacteria are specialized in this process, particularly when it comes to releasing phosphate, which is very important for the plant. These bacteria also carry out countless other important tasks, including one which is very special. Rhizobacteria form a sort of natural defense system around the roots. Anything attacking the plant is kept outside by the physical presence of these rhizobacteria. They ensure that there is no room for disease-causing bacteria. They have their own interest in this because the plant provides them with food. However, the bacteria also need help. They are not travelers. The bacterial colonies do not move back and forth from minerals to the roots. Most minerals found in soil are located outside the reach of the roots, and therefore also out of the reach of rhizobacteria. These can only live near the roots. As we have seen before, the zone of absorption is therefore very limited. Mycorrhizal fungi are able to drastically increase this absorption capacity. It may sound like a modern development, but it's not. The fungus has always existed, but due to modernization, its role has been neglected. Due to many years of using synthetic fertilizers, mycorrhiza is only very sporadically found in agricultural soils. Mycorrhizal fungi have always lived in symbiotic relation with the plant roots. Mycorrhizal fungus forms a living connection within the roots and creates an absorption and transport system. This is essential for healthy plant growth. Mycorrhiza in the roots is just as normal as chlorophyll in the leaves. This is beyond doubt. As stated before, the absorption roots of plants are 0.2 millimeters thick. This means that they can only grow in macropores, as shown here. Now we zoom in to see what happens when the plant gets help from the mycorrhizal fungus. The fungal threads are even thinner than most bacteria. They are only as thick as 3 microns. This means that these thin threads grow easily in the micropores, where the majority of nutrients and water are stored. Without help, a plant would never be able to reach these areas. It's not just the roots, but also the fungal threads that are responsible for the absorption of nutrients and water. The long, thin fungal hyphae that fully takes over the absorption of materials from the roots are able to provide disease resistance. Distantly located minerals that are bound to iron and calcium are now easier to absorb. These fine threads or hyphea can easily be a kilometer long in just 1 teaspoon of soil. Mycorrhizal fungi cause absorption capacity to be 7 times higher in average. This means that growing can be done with less water and that weeds have far less chance to thrive due to competition for space. The benefit to the fungi is the glucose produced by the plants. For the plants, the benefit is a larger absorption zone. This unique and constant interaction between the plant, bacteria and fungi creates a really fantastic symbiosis. The payout that the plant provides to its partners is water, minerals and glucose. The partnership between soil and roots requires healthy soil biology. Healthy soil contains organic matter from dead leaves, dead roots, and dead animals. This dead organic matter is broken down in nature by soil life to become humus. This creates a great deal of food for soil life, and the soil retains plenty of CO2. Years of using fertilizer has caused the humus to disappear from agricultural land. You could think of humus as the battery of the soil. It's where the energy is stored, the energy that the soil life needs to do its work. Without the humus, it is almost impossible to achieve natural soil recovery. It has long been thought that nitrogen fertilizer stimulates the soil life as more bacteria are able to grow. But to maintain their carbon-nitrogen balance, they are compelled to consume more organic material, which then enters the atmosphere as CO2. The symbiosis between plant, fungi and bacteria is not only a great partnership, it is absolutely vital. Without these transformers of organic material, we would all perish in excess organic material. Returning to the question we asked previously about how we can improve the soil, the answer must be, ultimately, plants improve the soil on their own. They do this through the symbiosis between plants, bacteria, and fungi. Plants are really the only soil improvers. Here we can see a clear difference between an absorption system without and with mycorrhiza fungi. The plant on the left is entirely dependent on the pH value of the soil and the supply of minerals. The plant on the right has roots that are able to optimally self-regulate the pH level and absorption via mycorrhiza fungi. This results in a healthy absorption that works perfectly with organic fertilizers. Using this natural system, we will achieve healthy soil that in turn brings healthy plants that can produce healthy fruit and vegetables. The way we deal with our soil has a direct effect on the emission of CO2 and the nutritional value of our food.